This is Dr. Lennon, and today we're going to be looking at mixture problems. So these are problems that arise quite frequently from linear equations. Usually what you have is you have a mixture of a couple of things, and you have some known facts about the quantity and perhaps the relationships of the constituent parts. So sometimes it's beneficial to organize these things in a table. Sometimes it's pretty straightforward and you don't have to do that. So let's go ahead and look at this first example. So this says Maria has $2.43 in quarters and pennies. So she only has two types of coins in her wallet, and she has twice as many pennies as quarters. So how many coins of each type does she have? Well, let's use some letters to represent the things we're dealing with. So let's let capital P be the number of pennies, so the actual number of those type of coins, not the value. So the number of pennies. And let's let Q equal the number of quarters. So not their value, just the total number of those type of coins. Okay, and then that additional piece, how are they related? Well, we know she has twice as many pennies as quarters. So she has fewer quarters, so if you double the smaller amount, that has to equal the larger amount. So essentially that means 2 times Q has to be the same thing as P. So they total to 243 cents. So it's easier to work with just the one unit, 243 cents, which means if you look at the total number of cents, that's pennies. Well, each penny is worth 1 cent, so that's going to be P, plus the value of the quarters. So the value of the quarters is going to be 25 times Q. So it's not the number of quarters, but their value. So 25 times Q, that is going to equal the total amount in cents, 243. So then what we can do is we can substitute. So what we want to do is take this equation and reduce it to a single letter. So our P in the equation we're going to replace by 2Q. So this P we're going to write as 2Q now, plus 25Q. This equals 243. So 2Q and 25Q are like terms, so you can add them together and you get 27Q equals 243. Q is now being multiplied by 27, so we can divide by 27. So we have Q is equal to 9. So we also need to figure out how many pennies she has. Well, we know pennies is equal to twice Q, so that's 2 times 9. So she has to have 18 pennies. So Maria has 9 quarters and 18 pennies. And then we can check to make sure that actually works. We could plug back into the equation and say, okay, well, 18 pennies plus 25 times the 9 quarters, that's going to be equal to 18 plus 225, which in fact does equal 243 cents. So that checks out. So anyway, those are basically our answers for this problem, and that one works out pretty nicely. So let's go ahead and look at the next example. So in this one we have Orlando. He's mixing nuts and cereal squares to make some type of party mix. So the cost of the nuts is $7 per pound, and the cereal squares sell for $4 a pound. So he wants to make 30 pounds of the party mix at a total cost of $6.50 per pound. So how many pounds of nuts and how many pounds of cereal squares should he use? So this one might be a good one for a chart. Again, let's use N for the, let's say the number of pounds of nuts. And then we can use C for the number of pounds of the cereal. So how can we make our chart? Well, again, we've got our nuts, our cereal, and then we have the mix that we want to finish with. So basically we're going to have 3 rows here. So nuts, cereal, and we have the mix. So what's going on? Well, we have kind of 2 things that we care about. We care about their weight, which is in pounds, but we also care about their cost. So again, we can fill in what we know and kind of use that to help us write the equation. So, so actually let's do cost per pound, and then maybe we can look at the total cost. So let's add a third column there. And that will help us get our equation, because the actual problem is also involving the total cost, right? Because we know the total cost because we know the total amount they want to use and the cost per pound. So let's look at that first. So let's go ahead and fill in the information. So we know that the nuts sell for $7 a pound. So we know that there's $7 per pound there. The cereal is selling for $4 per pound. What about the weight? Well, we don't know the weight, but that's what we let our variables indicate. So the weight for the nuts is N. The weight for the cereals is capital C. So to get the total cost from each of those, you just multiply across, right? If you had 3 pounds of nuts, 3 times 7 would be 21. That would cost $21. Well, if it's a letter, we just leave that letter there. So this would be 7 times N. Same thing for C. If you had 5 pounds of cereal at $4 a pound, it would cost $20. So we just multiply the 4 with the C. Okay, so what is our end weight? Well, we don't, the weight is 30 pounds. So up here in the problem, they want to make 30 pounds of the party mix, and they want to sell that for $6.50 a pound. So that's what we fill in the bottom row here. So $6.50 a pound. And now this last cell that I'm circling, we can fill in 2 different ways. So we can fill in the circle 2 ways. So this is how we get the equation. So on the one hand, we can multiply across the way that we've been doing. So we could do 30 times 6.5. But the total cost, we also know, would have to be the 7N plus the 4C. If you add the cost for the nuts plus the cost for the cereal. So, sorry, just moving it so we get it all on a frame. So let's multiply 30 by 6.5 and reduce that equation. So this equation can be simplified to 195 equals 7N plus 4C. So this is the equation we really want to solve, but how do we relate the number of pounds of nuts to the number of pounds of cereal? Well, that comes from the weight column. So the weight column, if you add N, the total weight from the nuts, so this is kind of like your, the first equation we just wrote down is your cost equation, and then we also have a weight equation. So the weight equation is your total weight, 30, has to equal the weight from the nuts plus the weight from the cereal. So how can we put these 2 equations together? Well, we can solve the weight equation for one of the 2 variables. Let's say we solve it for C. So 30 minus N is equal to the value of C. And then we can go ahead and plug C in up here where we see C in the top equation. And we can solve that, and that'll allow us to solve for one of the letters. So we have 195 is equal to 7N plus 4, and then we're going to replace that C by 30 minus N. And now we have a linear equation in one letter, which we should be able to solve. So distribute the 4, we have 195 equals 7N plus 120 minus 4N. We have 2 like terms on the right-hand side, 7N minus 4N, which simplifies to 3N. So we have 195 equals 3N plus 120. We want to subtract 120 on both sides. So we have 195 equals 3n. And then we can just divide by 3. So the total weight of the nuts in the party mix is, it looks like 65 pounds. And then we know, so 65 pounds, that can't be correct. Oh, I forgot to subtract the 120 from the 95. That's my mistake. I just wasn't thinking there. That should not be. Let's rehash that bit. I'm sorry. So let's go ahead and I forgot to subtract 120 from 195. So that comes out to 75. And then when you divide that by 3, we get 25 pounds for the number of nuts. So if 25 is n, we saw above that 30 minus n is equal to c. So 30 minus 25 is c. So 5 is equal to c. So we have solved for each of the two amounts of the quantities that make up the party mix. So essentially, the party mix is made up of 25 pounds of nuts and 5 pounds of cereal. So that's it for this problem. So that was a little bit tricky, but we saw how we could involve a chart to help us solve that problem. So let's go ahead and move on to the next one. Okay, so this is another common one where you have components of investments. So in this one, the one thing I'll point out is that we have two percentages involving the earnings. So remember, whenever we're working with percentages and equations, oftentimes we want to convert those to decimals. So 7% we're going to convert to 0.07, and 6.1% we're going to convert to 0.061. So basically he has two mutual funds. Oh, sorry, 6.1% is the combined percentage. The other account is earning 4%. So let's just call our accounts A and B. So A, we'll say, is amount invested at 4%, and B is the amount invested at 7%. So, again, we have two equations here. So the equations that we have here are going to be the total amount and the interest earned. So we can look at the account. If we want to make a chart again. So some people find the chart helpful, some people do not. But we'll look at the interest rate, and then the money invested, and then the total interest. If you multiply the interest rate by the amount invested, you get the total amount of interest. So we have three accounts we care about. We have account A, account B, and then the combined account, we can call it. So let's use our interest rates as a decimal here. So account A is 0.04, account B is 0.07, and the combined account is 0.061. So that's the combined interest rate that we see in the very last sentence. So the money invested, that's what we let our variables be. So we invest $A into account A, $B into account B, and then $14,000 is the total amount invested. So we have $14,000 as the total invested. So to figure out the total interest, again, we just multiply. So we get 0.04 times A, 0.047 times B. Let me erase that to make it a little neater. 0.07 times B. And then the total interest would be that 0.061 times 14,000, which comes out to $854. But again, we can get one equation because we know if we add the 0.04A plus the 0.04B, we have to get our total interest of $854. So we have, okay, so we have two equations here. We have the total amount of money invested, the A dollars in account A plus the B dollars in account B, has to equal the total investment of $14,000. So this is the invested amount, or the invested amounts. And then we also have the total interest amount. So we know the interest from A is 0.04A plus the interest from B is 0.07B, and that will equal the total combined interest of $854. So this is the total interest equation. So then, again, what we want to do is we kind of want to solve for one of the letters and replace it in the second equation. So let's just replace A. So A will be 14,000 minus B. So we can replace A in the second equation and go ahead and solve that. So 0.04 times 14,000 minus B plus 0.07 times B will equal the 854 total dollars. And then again, for this, what we want to do is we just want to expand and solve. So this is now a linear equation in one letter. So this is something that we've had a lot of practice with doing. So 0.04 times 14,000 is 560 plus minus 0.04 times B plus 0.07 times B has to equal 854. So we can combine the minus 0.04 and the 0.07, so we have 560 plus 0.03b. This equals 854, and then we subtract 560 on both sides. Let's scroll down to give ourselves a little more room. So we know that our 0.03b is going to be 294, and then we just divide by 0.03 on both sides since we're multiplying B by 0.03. So we get the amount in the account B is 9,800. So that's the amount in account B. So we know the two accounts have to add up to 15,000. So, or was it 14,000? 14,000, I'm sorry. So we know the amount in account A plus the 9,800 has to equal 14,000. So we just subtract 9,800 on both sides. So we get the amount in account A is 4,200. So this is our second amount. So if we want to write that answer in a sentence, we say $4,200 was invested at 4%, and $9,800 was invested at 7%. So those are the interest earnings in the two accounts respectively. So again, we can use that one using a chart. Again, maybe you saw the equations right away and you wanted to forego the chart, which is also fine. I find usually in word problems it's just helpful trying to be more organized. So let's go ahead and move on to the last problem here. So again, this is pretty similar because he has $8,000. Again, we have something with earnings. So $8,000 to save for college. His daughter's college. He wants to divide it between two accounts, one at 3.2% and another at 8%. How much should he invest in each account if he wants the interest on the total to be 6.5%? So this one is a little bit different because they're not telling you the amount of dollars. They're telling you the anticipated interest rate earnings that we're trying to figure out here. But that shouldn't be... So I think the same type of thing is going to work. So let's say A, the same setup at least. So A, let's say that's the amount invested at 3.2%. B, we'll say that's the amount invested at 8%, and then we know so again, the combined interest rate should be 6.5%. So, so that we have the account, we should have the amount invested we have the interest rate, and then we have the total interest. So again, we have 3 accounts in play. We have account A, account B, and then we have the combined account. So A is 3.2%, which is 0.032. B is 8%, or 0.08, and the combined investment is 0.065. Oops, I wrote my columns in the wrong order here, so let's copy actually all that information over. We should have 0.032 here, 0.08 here, and 0.065. So I mistakenly wrote the rates under the amount invested column. So what do we want? We want to write the amount invested. So the amount invested in account A is the variable we're using A. We're investing B dollars in account B. And the combined amount invested, we know that we have $8,000 to save. So the total interest, again, is found just by multiplying the amount by the rate. So we have 0.032 times A for account A, 0.08 B for account B, and 0.065 times 8,000, which is 520 for the total interest earned. Sorry, that I was trying to make the decimal point more clear, but probably I'm just muddying the waters. Okay, so we have our 2 amounts. We know that if you take the money from A plus B and add that together, you get $8,000. So this is the amount invested equation. And then for the second one, we have the total interest equation, which we get from adding the 0.032A and the 0.08B. Probably we're going to want to solve for B in this equation, so let's subtract A. So B is going to be 8,000 minus A, solving for one of those letters because we know we have to substitute it. So what do we have here? We have, well, our interest equation is 0.032A plus 0.08B. This equals that 520. So this is the total interest equation. And then what we want to do is we want to substitute out 8,000 minus A for B. So 0.032A plus 0.08 times 8,000 minus A is 520. We need to distribute that 0.08, so 0.032 times A plus 640 minus 0.08A equals 520. Then we can combine 0.032 A minus 0.08A is negative 0.048A plus 640. This equals 520. So then what we're going to do is we're going to subtract 640 from both sides. So we're just left with minus 0.048 times A. That's equal to negative 120. So we're multiplying A by negative 0.048, so we just divide by negative 0.048. And we get our value for A. So capital A is equal to 2,500. So again, that's the amount invested in account A. Account B, we have invested, so the total amount is 8,000, so we know 2,500 plus B is the 8,000. So we just subtract 2,500. So we know B is equal to $5,500. So again, we could write a sentence here if we want. Again, it's just kind of rehashing what the variables mean. So basically $2,500 was invested at 3.2%, and 5,500 was invested at 8%. Okay, so that is it for these examples today. Again, basically the main thing is you need to be able to write down the two equations that you're going to put together to solve any of these type of mixture problems. I think using a chart can be helpful when you have a lot of information to organize, but what's the general process? Well, we always kind of had two things that they were looking for. So we started out by naming our variables, then organizing the things into a chart, which typically had three rows, because we would have the separate things, and then usually they're combined in some fashion. Hence the mixture. We're mixing the two quantities to come up with a third quantity. And then from those two things, we can write down two equations. Once we write down the two equations, we need to combine them, which we were doing by substituting. And then once you substitute, we end up with a linear equation with just one letter that we can go ahead and solve. So give a few of these a try and let me know if you have any questions, and I will be sure to answer any of those for you. So this is Dr. Lennon signing off, and I will talk to you soon.